Here are here are solutions for quiz 7 from Math 111. All right, first one, find and simplify g of f of x. Okay, you're asking me to do g of, let's see, f of x is 5 minus x over x minus 1. And the way I can figure that out is I know what g of x is, so g of this mess would be 1 divided by 5 minus x divided by x minus 1. Maybe instead of 1 divided by, I'll call it 1 over 1 divided by, so that now I have a fraction divided by a fraction. Because I know how to do that, I just multiply them, but I have to flip this guy upside down. So if I flip upside down, I get this guy right here. X minus 1 over 5 minus x. That is what g of f of x is. Find and simplify f of g of x. All right. F of, let's see, g of x is 1 over x. F of x is this mess, so what I want is 5 minus, instead of writing x, I'll write 1 over x. And then instead of writing x down here, I'll write 1 over x minus 1. And then if you think back from earlier in this term, we had things like this where it's not a fraction over a fraction. If it was, we'd know what to do. It's kind of a difference of fractions up here. But I can take care of that. I can find a least common denominator. Let's see, maybe I'll throw another color in here. Let's think about this as 5 over 1 times x over x minus 1 over x divided by 1 over x minus x over x. Yeah, I don't know why I changed color. I was going to try to add more to this one, but I didn't. But the idea here is instead of 5, you can think about that as 5 over 1. You can multiply it by x over x because that's just 1, and that'll give me a common denominator up top here. Same idea down here. Instead of minus 1, you can think about it as minus 1 over 1. Multiply that by x over x, and you get this. So if you put everything together, you get 5x minus 1 over my common denominator of x divided by 1 minus x over my common denominator of x. And if you the way you divide fractions is like multiplying, but you multiply by the reciprocal of the denominator. So this is 5x minus 1 over x times x over 1 minus x. Now you can cancel out those x's and end up with 5x minus 1 over 1 minus x. And that's your final answer. Okay, find the domain of this guy that I just found. Okay, so for the domain of f of g of x, I need to first consider the domain of g of x. So domain of g of x. Let's see, g of x was 1 over x. So the domain of g of x is everything sub 0. There's no square roots going on there, so we don't have to worry about that. No square roots going on in this function. Got to make sure you don't divide by 0. The only x that'll make you divide by 0 is if x equals 0. Then we have to figure out the domain of the composite function of this guy. And same thing, no square roots going on here, just don't divide by 0. The only thing that'll make you divide by 0 is if x equals 1. So is everything except 1? So my final answer is everything from negative infinity up to 0. And then everything from 0 up to 1. And then everything from 1 up to infinity. Something like that. That's finally the end of the first problem. The second problem, okay, so the idea here is we have a function h of x. It's not 1 to 1. But we can make it 1 to 1 if we restrict the domain. The way you see where you want to restrict the domain is, like many things in this class, by completing the square. So to complete the square, might as well change colors again. I'm going to throw brackets around my terms with x's in them. Then I'm going to factor out a 2 from that and get x squared plus 6x minus 10. And I'm going to complete the square on the stuff inside the brackets by taking half of this number and putting it here, and then subtracting this number squared. Gets me to here. Then finally I'm going to put the 2 back in to get 2 times x plus 3 squared minus 18 minus 10. Okay. And I guess I could take this one step further. I don't know if you need to go a step further, but it might be helpful to have at some point. 2 times x plus 3 squared minus 28. Really what you care about is the x-coordinate of the vertex. So what we have here, the x-coordinate of the vertex is at -3. So what I'm saying is that my graph looks something like, there's -3 and here's -28 way down here. Looks something like this. Pretty poorly drawn parabola, but you get the idea. And so if we restricted the domain to everything to the right of this dotted line that's supposed to be at -3, then our function would be 1 to 1, right? This guy here is always increasing. So what we want is our domain to be everything from -3 up to infinity. So I guess to answer the question, a would have to equal -3. Okay, all that just so now we can find the inverse function. Finding the inverse is a little bit hard. I mean, the general idea is you change h of x into a y, and then you solve for x. But solving this for x isn't easy, because there's an x squared and an x. Turns out solving this guy for x is a lot easier. So what I would do is I would say y equals 2x squared plus 12x minus 10. But using my work from part A, I know that that's the same as 2 times x plus 3 squared minus 28. So to solve for x, I'd add 28 to both sides. And then moving up here, I would divide by 2 and get x plus 3 squared equals y plus 28 over 2. Take the square root of both sides, you get x plus 3 equals the square root of y plus 28 over 2. Note I didn't put a plus or minus here. Normally you do put a plus or minus there, but since I've restricted the domain, essentially what I've done is I've gotten rid of the negative part. I've gotten rid of all of this, only focusing on the positive, so I leave this as positive. So my final answer, or not quite my final answer, if I solve for x, I'd get -3 plus the square root of y plus 28 over 2. So this right here is the inverse function. It wants it written a little bit differently. It wants h inverse of x. It wants x to be the variable. So I'll change the y into an x and call it -3 plus the square root of x plus 28 over 2. It's negative out here. And this right here is h inverse of x. And that's finally the end of this quiz.